Welcome back to the Ccna series. Let's open up Lesson 2 of Module 2. In this session, we're going to unpack ARP, the Address Resolution Protocol, and why it's the quiet workhorse that lets your network actually move traffic. The core idea is simple. IP addresses tell us who we're talking to, but on a local network, we need MAC addresses to figure out where they actually are. ARP is what bridges that gap. So let's frame the problem more concretely. Your application has an IP address, say 192.168.1.20, and it's perfectly happy with that. But the actual Ethernet frame that carries the data out the wire needs a destination MAC address, and that field starts out empty. That's the gap. Layer 3 knows who, Layer 2 needs to know where, and ARP is what resolves one into the other, but only within your local subnet, inside the same Layer 2 broadcast domain. So how does that gap actually get bridged? The mechanism is surprisingly simple. Shout the question, listen for one answer. The sender broadcasts an ARP request to every device on the subnet. Essentially, who has 192.168.1.20? Everyone hears it, but only the host that actually owns that IP replies, and it replies privately, unicast, with its MAC address. The sender then caches that mapping so it doesn't have to ask again next time. Request goes out wide, reply comes back narrow. That's the whole dance. And that cache is exactly what we're looking at here. On a Cisco device, show IP ARP lists every mapping the router currently remembers, IP address, the MAC it resolved to, and an age in minutes since it was last refreshed. The dash next to 192.168.1.1 means that's the router's own interface, so it never ages out. The others will sit in the table for about 4 hours on Cisco before expiring, at which point the device simply re-ARPs and starts the clock over. Before we move on, two things are worth burning into memory. First, ARP never leaves the local segment. If your destination is on a remote network, your device doesn't ARP for that far-away IP. It ARPs for the default gateway's MAC and lets the router handle the rest. Second, ARP completely trusts whatever reply it gets. There's no authentication, which means an attacker on the same segment can send forged replies and quietly steer your traffic through their machine. That's called ARP poisoning, and we'll come back to it when we hit security. And that wraps up our deep dive into ARP. Next lesson, we shift one layer of the stack and follow the frame itself into the switch. We'll unpack switching logic, how a switch builds its MAC address table, the difference between store and forward and cut through, and exactly what happens when a frame hits that interface. If this clicked for you, hit subscribe and turn on notifications so you don't miss it. I'll see you in Lesson 3.